Okay, then a little further on why this and this works. Why do they both work in this table right here? Isaac?
Because the negative squared is a positive, and the positive squared is a negative. So
the positive squared is a what?
The positive squared is a positive.
Okay.
So even if it is absolute value, it still be positive.
Okay, so when I teach this, I need y'all, not teach it, well, technically teaching it now. Y'all have been discovering this. I need y'all to understand that when you square, oh, no, that's leading into page 3. I can't tell y'all that. Okay, you know why they both work. I'll go that when we group on page 3. Okay, so, and then we said the equation is called a what class?
Quadratic function.
Quadratic function. All right, and then we move on to the second page. And I ask you all to Google how tall a basketball hoop is, and you said that the height was what? 10 feet. And then we use the quadratic. Again, this function represents the what?
Ball.
The ball, and it's specifically his shot. Dante's shot. So, the ball goes through the hoop after how many seconds, class?
3.
3 seconds. 3 seconds. And then how did you, Nicole, how did you check that it was, because y'all gave me some crazy answers in the beginning, and y'all finally got that. How did you come up with 3?
On Gizmo, we put it into the table, we put those two values plus the
No, I'm talking about before we got here, how did y'all know it went through the hoop at 3 seconds?
Oh, because the x-axis is time, and then at the top is when it went through the hoop, so at 10 feet and 3 seconds, that's how tall the basketball hoop is.
Okay, so some people were getting stuck on, I think this was other class, they were like, oh, the 10 feet is right here. Why is that the ball not going through the hoop?
Because it's not at the topmost point.
Okay, so it's not at the topmost point. This topmost point is doing what? What is happening at this topmost point, Henry?
It's starting to curve down.
It's starting to curve down. You can't make it if it's like in the midair. Like, it's done. Like, it's not there yet. So some people had here, and then some of y'all was guessing, y'all was looking at the video, and I said, no, he missed on the video, and I'm over here. He missed on the video. I said this is the picture of him moving to the origin, representing the origin, and he's making the shot. And then we had this equation. The equation was what, JJ, that everybody has come up with, because y'all done with this part.
Negative x squared plus 4.4x plus 5.3.
All right, and so what I did not, I can tell y'all before I made this lesson, what I did not bank on is that okay, I asked y'all to verify mathematically if your equation was correct. And then how did you, Rhea, how did you mathematically verify that this equation was correct?
So when we input it at the Gizmo thing, when we made x3 and y10, the value was 4.4, because when we looked at the table, all of the values,
Don't get lower. All the values were what?
or all of the values corresponded with the table.
Okay, so your table had to show a value for y of x being 3 and y being 10. If this. JJ, y'all ran into what situation?
We were trying to overcomplicate it, and we didn't think it was like that simple.
But y'all ran into what situation though?
Plugging it in.
Plugging it in, and what was the situation y'all ran into here? Was it y'all that ran into this? Was it y'all? Maybe it was other class. Did somebody come up with an equation that worked and I said that's wrong? Was it this class? So nobody here, so nobody is. Fourth block there. Okay, fourth block came up with an equation that worked. And I didn't bank on that, and I wouldn't even think about that. So the equation worked, but when I told them to look at the graph, it was wrong. Like the points, this point was off, these points were a little over, and so they had a 3 and a 10.
That was
y'all? Okay. Okay. Wonderful. I just had to jog up in with. Okay, so they had a 3 and a 10 in the table, but the graph was off, and so it worked. There was a 3 and a 10, but it must produce the same graph, which was a good learning point because I didn't even think that was going to happen, but it did. Okay, so and then this is the main thing I need y'all to take away. Take away. All right, so at the bottom is how A, B, and C are affecting the graph. So we said, yeah, we looked at the table, that's how we looked at that. How did changing A affect the graphs? Okay, so I didn't tell everybody, but there are more than one thing that A does. So somebody has one thing, somebody has the other, unless there's a one group in here that has both. Okay, Sam, you look like you're ready to talk. Yay, Sam. Sam, no, I think y'all have. No, yeah, you have that way. Sam, how did A affect the graph?
If it's positive, it will go like this. If it's negative, it will go like this.
Okay, so if it's positive,
It will go like a U.
it'll look like a U, and if it was negative,
It will be like an upside down.
That's an N.
it'll look like an N. All right, did anybody have anything else other than that? I think majority of people described that. Henry.
I said it affects like the width of
Okay, how specifically does A affect the width of the graph?
it's if it's positive, it's gonna be larger. I don't know.
Anybody figure out how it's A? Because that's the other thing that A does. It does flip the graph to make it look like a U and look like an N. Rhea.
I guess the closer it is to 0, then it'll be wide. And
Okay.
then because if it was like 0.1, then the graph would be like on the verge of like flipping, because when it's negative, it looks like
Okay, so let me pull this up so they can see. And you're right, Rhea. Let me pull this up. So Rhea's saying the closer you get to 0, the wider it is. The further away you get to 0, the narrower it is.